Hi everyone, welcome to this presentation on reactivity in the periodic table. Here's what we'll cover today. First, we'll go over key terminology and how the periodic table is laid out. Then we'll look at atomic size changes as you move across or down the table. Finally, we'll examine reactivity trends in specific groups like group 1, 7, and 0. Let's begin with some important definitions. The valence shell is the outermost shell of an atom. Valence electrons are the electrons in this outer shell, and they're key to how atoms react. Atoms are considered stable when they have a full outer shell. This is usually 8 electrons, known as the octet rule. Helium needs 6 valence electrons to fulfill the octet rule. Neon needs 0. A group is a column in the periodic table and tells us how many valence electrons an atom has. Group 1 has 1 valence electron, group 2 has 2, and so on. But note this only applies to groups 1, 2, and 13 through 18. A period is a row and shows us how many electron shells the atom has. The first period has 1 electron shell, the second period has 2, and so on. Now let's talk about atomic size. As we go down a group, atom size increases. As we move across a period from left to right, atom size decreases. Let's explore why this happens. As we go down a group, each element has more electron shells. The inner shells shield the outer electrons from the pull of the nucleus, so the outer electrons feel less attraction. As a result, the atoms become larger. Across a period, atoms gain more protons, increasing the nuclear charge. Even though electrons are being added, they go into the same shell, so the increasing positive charge pulls electrons closer. This makes the atomic radius smaller as you move from left to right. Reactivity is all about how easily an atom can lose or gain electrons. Highly reactive elements often form ions, either by losing electrons, like metals, or gaining them, like nonmetals. Elements that tend to share electrons are less reactive and usually form covalent bonds. The periodic table is a great tool for predicting how elements behave. Elements in the same group have the same number of outer electrons, so they tend to react in similar ways. This helps scientists make educated guesses about reactivity, physical properties, and bonding types. Group 1 elements, the alkali elements, get more reactive as you go down the group. Why? Because their atoms get bigger. Their outer electrons are further from the nucleus and feel less attraction. This makes it easier to lose that one outer electron and react. Losing this electron gives them a full outer shell underneath, making the atom stable. Group 7 elements, the halogens, become less reactive as you go down the group. They need to gain 1 electron to be stable. But as atoms get bigger and the outer shell gets farther from the nucleus, it's harder to attract an extra electron, so reactivity decreases down the group. Noble gases are found in group 0. They are inert, meaning very unreactive, because they already have a full outer shell. This stable configuration makes them happy just the way they are. They don't need to gain, lose, or share electrons.